Hello viewers, in today's video we will learn about linear regression. So let us first understand what is linear regression. So linear regression is a statistical technique that models the linear relationship between a continuous dependent variable and one or more independent variable by finding the best fitting straight line of the data. So in front of us we have two data. Okay, for this we will try to find the linear regression fit, and it is also used to comprehend and quantify how changes in the independent variables relate to changes in the dependent variable, allowing for the prediction of unknown values based on known ones. So here the main focal point is the dependent variable is y, the variable you are trying to predict or understand, and independent variable x, the variables are used to predict the dependent variable. And here we will get a linear equation. So a linear relationship is expressed as a straight line, like y is equal to mx plus c, or y is equal to a plus b, or ax plus b. So here m is my slope and b is my intercept, and slope will tell you how much the dependent variable changes for a unit change in the independent variable. So here m is the slope, and the value of the intercept, or the value of dependent variable when the independent variable is 0, and the prediction error or residuals, the vertical distance between an actual data point and the regression line, which the model aims to minimize. Okay, now the best fitting line minimizes the discrepancies between the predicted values and the actual data point. Okay, now let's start doing the linear regression. So we will do with the Excel, and also we will do with the origin, and then we will try to see what are the output that we are getting in the Excel and what are the output we are getting in the origin. So here we will try to use the scatter plot. So here you can see the values are not linearly. Okay, the R square must be with poorly correlation. Now let us see the equation, and you can see this is my R square. So it shows the data is poorly correlated. Okay, now we will try to do the same thing with another data. Same thing we will do here. So you can see the data is bit very well arranged, and now try to add a trend line. So let's add a trend line linear, and also you can also set the intercept if you want. Now if you compare with the two, so this has a poor correlation and this has a better correlation. Yes, also the slope here is around 0.9 and this slope is 0.5. Okay, and intercept here is 2.2 and intercept here is 0.824. Now let us do the same thing with the origin. So we have origin file here. Already in my previous videos we have talked about how to import data through the origin. So I already imported both the data. So these are the same data, you can see. Okay, same data. Now we'll try to plot the same data. So we'll say plot scatter. So we can see here also same nature, and then go to the analysis, go to the fitting and use the linear fit. So you can use the old ones. I will show you how it is done. So here you will see a couple of options. Okay, fit control, You can fix the intercept, fix the slope. Okay, you can also play with other options, quantities, residual analysis. Also here also we have a couple of more options. You can just click and see fit statistics, how many points, like these. You can get more R value and all, fit summary. So these are already selected by default. And residual analysis also, output. So we have a couple of options like graph, okay, dataset identifier, fitted curves, fit residuals. Okay, there's so many options. Fitted curve plots. Okay, confidence levels is around 95%. Find xy. That's the same that we saw in the SPSS. Then we have residual plots. Okay, now we'll press OK. And also here have like manual, auto, none. So we prefer to choose manual. Okay, and then you can, if you want to do yes and do no, no and don't bother with. So let's press yes. So here, this is my table that we are going to look for. So we'll go to the graph 3 instead of going to this. So here is my table, which you can amend. If you want to delete this, you can delete, because we are going to copy this table to the doc file and understand what is the meaning of weight, no weighting, intercept, slope, residual sum of a square. You can even compare that. Here also the R square is 0.767562, and here also the R square is 0.75, so it's almost same. Now we'll go back to the data and see for the second set of data. So here we will do the same thing. Then to the same data, analysis, fitting, linear fit, or you can use the last used, because already I have shown you these steps. So we'll use the last used. Yes. Then go to the graph again, and this is my table that we are looking for. So you can match in the Excel. So it's 0.9952, and here also this is 0.9951. So this is R square and this is adjusted. So usually the Excel doesn't give you the adjusted one, it gives, and I think there are pretty options that you can see about the adjusted also, if there is an option. So it's not showing that option. Now let us try to understand about the, for the first data, you can see the intercept was this one, slope was this one. So this is my best fit regression equation. Okay, and no weighting means all data points were treated equally. Residual sum of a square indicates the total square deviation from the fitted lower line. Lower RSS means better fit, and the Pearson coefficient is 0.86. So strong positive correlation between the variables, and this is about 75.6% of variance in y is explained by x, and this is adjusted for predicted, confirms good model performance. And the positive slope indicates a direct proportional relationship between x and y, and increase in x results in increase in y, and intercept represent the value of y when x is 0. The correlation coefficient R is point strong positive relation, linear association, while the R square confirms the 75% of variability in the independent variable is captured by the model. Okay, then this is going to provide the linear model, and this is the summary. Okay, and then let us see the other, for the other model we have same thing here, but here the residual sum of square is 1.17, and here it is 25.29, and this very low indicates minimal deviation, and this one indicates, okay, so this is the difference between. So there is predicted observe signifying excellent fit, and this indicates extremely strong positive. The R1 creates an R square point dependent variable explained by the independent variable, and this the adjusted confirms the model accuracy even after adjusting for the number of predictors. Okay, now we can go down and see the couple of more points. Linear regression model, so this is the equation: exceptionally high degree of correlation and coefficient of determination. The regression indicates that the data set follows an almost perfect linear relationship with 99.5% of the observed variation explained in the model. This reflects excellent experimental precision and robust linear dependency between these study variables. So this was all about using of linear regression, or you can say the performing linear relationship, the linear regression with origin and Excel. So this was the little difference. Okay, I hope you all got how can we do the linear regression with using origin and Excel.